All right, here's an example of an exponential word problem. So we have already worked with compound interest formulas. So if you remember, A is going to be your end amount, P is your initial amount, the principal, T is the time years at an annual percentage rate, R is that decimal form of that interest rate, N represents the number of compounds per year. So here's our question. How long will it take 25,000? So that is our initial amount to grow to $500,000. That's our end amount. At an interest rate of 9%. So as a decimal, 0.09, compounded monthly. So that's your N is 12. And we want to find out how long it'll take. So our time is our unknown. So that's what we're going to be solving for. So we're going to go ahead and substitute those numbers into our formula. So 500,000 will replace with A. 25,000 will be substituted in for P. Interest rate, 0.09. Compounded monthly, so 12. Compounded monthly, which is 12. And T is unknown. So we want to solve this equation for T. So we want to try and isolate this exponential. So the first thing we're going to do is we're going to divide both sides by 25,000. So we have 1 plus 0.09 twelfths raised to the 12t. Then what we can do is we can take and type that 500,000 divided by 25,000 and enter it in our calculator to give us 20. Now we can take the common log or the natural log of both sides. I'm going to take the natural log. I'm also going to simplify that parentheses. Now I can use my power rule. I can take that 12t and bring it down in front. Now I divide both sides. By 12 times the natural log of 1.0075. Do the same thing on the left. The natural log cancels, the 12 cancels, and we're left with just t on the right. The left side is our fraction that we would want to type into our calculator. And when you're done, when you type that into your calculator, I suggest that you pause. You get 33.4. So what does that mean? It takes about 33.4 years for that 25,000 to increase to $500,000.